Okay, so let's start our discussion for today. Yesterday we just had few minutes towards the end of the session, so I just introduced you to what our class is, right? What do we mean by object? But we have not yet seen what is the difference between a class and an object, right? But we'll see it today. At present, we have been using these terminologies interchangeably, but today we'll see in detail what is a class and what is an object, right? So if you remember, we when we started our discussion, I told you something about what is an abstract data type, right? So we defined it as something where in an abstract data type, you know what you can do, right? But how it is done, you don't know. It means the implementation details are hidden from you, right? And I had given you examples of driving a car where you know how to drive a car, but you don't know what is actually going on in the engine once you press some pedal or once you turn the steering and so on, right? Then I had explained you with the example of a fan that if you want to turn it on, you just press the button. You don't care what is the circuit diagram, how electrons flow, and how the fan starts moving all of a sudden, right? And from the perspective of programming, if we talk of abstraction, right? So maybe a good example is built-in functions. Like whenever you need square root, you simply know that I have to call this function. You don't care what is the definition of this function, means what is the body of the function and how it is computing square root, right? You just know there is a function square root. If you know, if you need to find square root of a number, you simply call this function without worrying how this is implemented, what is actually the source code that someone has written here, right? So this is an idea of what we call abstraction, right? That we we are we are interested in getting our job done rather than the low level implementation details, right? Then we discussed this terminology encapsulation, right? So I told you that um, the word may sound a bit heavy, right? But you can easily understand it by correlating it with the capsule, right? So I told you in programming, we have a capsule which is like a package, but in this package we will have two things. We'll have some data and some functions, right? And this is basically what in a little while when I'll be writing a code, so this would be actually our class, right? And I told you that this would be very similar to structure. And we also had seen yesterday that what happens if we have a structure or a class, right? But when you make a class, so in general, what you do is you will have to you can say different entities, data and functions. So normally we restrict access to data. By restricting access, we said that you cannot directly access it from the main, just like you do with a structure, right? I had shown you yesterday. And to the functions, you actually let the main access these functions from outside this capsule, right? So I told you that if, for example, there is some data here which main wants to access, so rather than directly going to the data, main will request a function and the function will actually access the data, right? And I had given you example of maybe student advisor and HOD that you cannot directly access HOD, so you have to go through PA or student advisor, right? So today we'll mature this discussion and I'll be writing some programs which will further explain this concept, right? So let me just continue where we had left yesterday. Okay. So I think we were doing example with a point, right? So I will continue the same example so that we focus more on developing the ideas rather than changing example every time, right? So our objective is that we want to, we have a problem in which we have points like this, right? So this is 2 and this is 3. This is our y-axis, this is our x-axis, right? So we know, for example, this is a point P and the coordinates of this point are 2, 3. Okay. So you see, you can represent them by two different integers, x and y. But the problem is that suppose then you have another point, then you have another point. So it means for this you will take x1, y1, x2, y2, x3, y3. So rather than that, a good idea is that since point is something which is one entity, right? A point will have x coordinate as well as y coordinate. So why not make a data type for point, right? And I told you yesterday that in every programming language you have some basic data types available, and using them you can customize them to make your own data type, right? And you have been doing this previously, maybe consciously or unconsciously, that when you create a structure like point, so you are actually creating a data type, right, which has one integer which is x coordinate and another integer which is y coordinate, right? Now point is a data type, so just like you have something, say you write int a, now you can write point p. Okay. The only difference is that p is a composite data type, so p will have x and y, and you can assign them values that x coordinate is 2 and y coordinate is 3, right? So a very similar idea is with classes, but as I keep telling you, there are some differences, and as we progress, these differences will become more evident, right? So we say, okay, equivalent, what we have structure in structured programming, so the equivalent is class, right? Although class is much more rich, as we will see. So now I try and write this, okay? But I also told you that in structure, if you don't write anything by default, everything is what we call public. Okay, I didn't write anything, but it is public. Public means that from the main you can directly access it using dot. You can write p.x, you can write p.y. In classes, if you don't write anything by default, everything is private. Private is something which you cannot access from the main using the dot operator, right? But it's always a good idea that we don't leave it blank. We always write it to make it clear. Okay, so generally whenever you'll be making a class, so we say, okay, I have two sections. One section is private and the other section is public. Okay. In most cases, your data will be here, and in most cases, your functions will be here. But this is not something that is a rule of thumb. You can have some data which is public, or you can have some functions which are private. But this is what is generally followed. And why is it followed? That we'll see later, right? Why we are doing that. But syntax wise, you can have data here, you can have data in the private, data in the public, you can have functions in the private, you can have functions in the public, but practically in most cases data will be private and functions will be public, right? So let me just write some data. I'll not write functions yet, I'll just write some data. Okay, so since we are writing the point class, so the data would be one integer which is x and another integer which is y. Okay, and with that we let's let's use this data type in the main. Okay, just like we did with the structure. So maybe this is our main. Okay, so I told you that by writing this, now point is a data type, so you can write something like point p. Okay, now we also have to discuss what will actually happen at the back end, right? So when you write point p, you have a variable which is p, but now p actually has two components. Okay, p also has an x, p also has a y. Okay, so it means there is some garbage value, we don't know what is here, but the important thing is that this x is taking 4 bytes. Okay, this x is taking 4 bytes and this y is also taking 8 bytes, so it means it is total taking, sorry, 4 plus 4, it is taking 8 bytes in total. Okay, another important thing that I would like to discuss is that you see, if you see this statement, point P, okay, as I told you, it is very similar to the way you write int A. A is variable, int is data type. So here P is your variable and point is your data type. Okay, but when we are dealing with classes, instead of calling it a variable and calling it a data type, okay, a better terminology is that we will call it an object. Okay, and we will call it a class. So now you see, class is actually your data type, but you have written this is your class, and you, when you declare a variable of the class, it is a variable, p is a variable, but since point was a class, so instead of calling it a variable, we will be calling it an object, right? So this is, previously I did not tell you, so today we have seen this, that what is, if someone asks you what is an object, so object is basically simply a variable but of a class. For example, if this point here, when I had written p, this is also a variable, but I'm not calling it an object because point was not a class, point was a structure. Okay, similarly when I'm writing int x, x is also a variable, but I don't call it an object because this integer is not a class. But when I'm writing point p, now p is a variable, but since the data type is a class, point was a class, so instead of calling it a variable, a better way would be that I would be calling it an object, right? So in other words, when you are making a class, you are actually defining a data type, and when you are making variables of that class, you are actually calling them objects. Okay, so let me just clean this, write something, and then I take your queries. Okay, let me just get rid of this. Okay. Okay, so now let's see that what happens if I have point P And yesterday I told you that if it's a class, now you cannot do like this. Okay, if you try and do this, your program will not compile, it will give you errors. Why it will give you errors? Because x and y are private. If I write x and y in the public, these are legal statements, right? But since I told you in classes, normally whatever data we have in the class, we keep it in the private. So that's why these are not legal statements. It means you cannot assign value to data members just like you were doing in structure. That is not possible. Okay, then you might be wondering how to assign value. Okay, so we'll see that, right? But if you have any queries till now, please let me know. Then we see how we can assign values, how we can print those values. Okay, now let me convince you by writing the same thing. Okay, so it will be a cleaner version, so you'll get to know what we have there, right? So I'll just write class point. Okay, then I have integer x and integer y. Okay, and for the time being, I'm not writing public anything. I just have a class point. It is very similar to structure. The only thing is that I have introduced this, which is called, if you remember, I told you it is called access specify. Okay, now this is a data type. Okay, so what I can do is now I can write point. This is perfectly fine. Okay, but now see what will happen if I try to do this. P dot x is 2. Okay, now you see it is giving me an error. What is the error? Point x is inaccessible, as I told you. Why is it inaccessible? Because it is private. Okay, on the other hand, you see, just to show you, I make it public. If I make it public, now you see the error is gone. Now we don't have any error. Now it has become a legal statement. But now this is very similar to what you were doing in structure, right? But definitely we don't want it public, we want it private. Okay, and just to give you a hint that why we don't want access on data, like I'll cover this in detail maybe at a later stage. But you see, when you are working as a developer, you will be making different classes. Okay, for example, you will make a class point, you will make a class time, date, and so on, and maybe you will make them available to someone. Okay, so someone else will be using your classes, right? Just like you are using the square root function, someone else has written the code and you are only using it. So once you are maybe a developer, you will make some classes, time, date, and something, and you can sell that. Okay, I have a class time. If anyone is making a system where time is required, for example in exam or somewhere, you can use my class. Okay, so what happens is now, for example, if you are dealing with time or date, so you see, let's take the example of date. Date has day, month, and year. Okay, you know that day can be from Monday to Sunday, month can be from 1 to 12, year can be something, right? And every month has fixed number of days and so on. So suppose if you are making the class, so this is the part that you will be writing, which is here, which is on the top, right? And main will be written by someone else who will be actually using your class. So what if someone directly accesses the data and assigns them some illegal value, right? For example, someone assigns a value of 50 to a month. Someone assigns a value of a day which does not exist. Someone assigns 32 to number of days in a month, right? So what will happen is that your program variables will have some meaningless value, and you will not be sure what state your program is. So that is why what we do is, instead of letting the user directly access data, which can you see, user can provide any value. If you are going to an ATM machine, suppose instead of typing password, you simply press some nonsense keys. So what if, you won't like the machine to crash, right? You will want the machine to give you an error message that the password is incorrect. If you, for example, instead of digits, you start pressing a static key or some other key and the machine crashes, you won't appreciate it. That is exactly the same case, that when you are making a program, if someone provides an illegal value, we don't want our program to crash or give you some useless output. We want our program to behave gracefully. That is why whenever user is wants to set some value, you will say, okay, you don't set it, you give it to me. I will check if it is valid, only then I will set. Okay, that's why. And how do we do that? I will write a program for that. Don't worry about it. Just understand the concept, that why we say p dot x should not be allowed. Why we say this is not a good idea, because suppose we say that x cannot be x is a distance and distance cannot be negative. So what will happen if someone gives this value, say 100, right? So on the other hand, if we tell the user that you give me value, I will see if it is legal or not. If it is legal, I will assign it to x. If it is not legal, I will ask you to correct, or I will assign some default value, right? So this was just, you can say, a quick word on why we want to make data private. But naturally, as we write more programs, I'll give you more details. But just to convince you for the time being, this is what I can tell at this stage, right? Yes, do you have any confusion so far? Okay, so let me quickly write the class with which we were dealing. So class was point. Okay, and then we have, so this is what we had previously. Okay, bas itna tha and nothing else. And this is our public section. For the time being, it is like empty. Okay, ji. Okay, and maybe here we have main. Okay. So as you must be wondering that, okay, I can write point P, and we also know that when we write this in memory, this is P, it has X, it has Y. But as you are saying, if you cannot assign a value to it, that then what is the point in having these X and Y, right? Because I'm repeatedly telling you that you cannot give it a value. So you must be thinking, if I can't give it a value, then what is the objective of these, right? So now is the time that we say, okay, let's give it some value. So since this is the very first example, so let's keep things simple. Let's say we want to give it a fixed value, right? We want, say, X and Y to be 10, 5, or anything, right? Initially, let me give it some fixed value, and then we'll change the value. So if you want to give it a value, what we'll do is we will make a function within this class. Okay, so I'm making a function just like you make another function. Okay, there's a return type, say void, and I call it, say, initialize. There are no arguments. And now what I do is I give some values to X and Y, right? Presently, I'm just giving fixed values. Later, I'll change it. Okay. Now you see what is happening. Now it is important to see again this capsule. Okay. Now what we have done in this capsule, we have X and Y. Okay. And in this capsule, we also have a function which is in it. But the important thing is that, let me change the color, that this X and Y I am putting in a red circle. Okay. And the init, which is public, everything which is public, I'll be making a green circle so that you can actually relate with it. Okay, so red is private, green is public, and outside somewhere we have our main. Okay, this is our main. So as I told you, main cannot access this red part, but main can access this green part. Okay, so what main can do, just like you in case of structure, if this was a structure, you will write p dot. After dot, you can write anything which is public. Okay, but in public we don't have any data, we have only function. So you can call this function like this. Let me write, and then I explain something like this. Okay, so this is the key statement that we'll be discussing now. Previously you have been calling function. Okay, but those functions which you have been previously making, like add, subtract, in case of a calculator, they are called global functions. Okay, or they are called standalone functions. Now here, if you see this part, it is very similar to the way you write a function, but there is only one slight difference. What is that difference? This function is inside this class point. Okay, and when a function is inside a class, we call it a member function. So if you want to use some technical terminology, you will say init is a member function of class point, which makes sense, right? Because you can have a program in which there are many classes. So if I say init is a member function, you might ask of which class. There's a class time, point, faculty, student. So that's why a good way to call it is, you can say init is a member function of class point. Now, what will happen when you will call it? Okay. Now you see this. This is very important. Since it is public, so after dot I can write anything which is public, right? But in this public I don't have any data, I only have function. So it means I can write p dot, I can call function. So this is the way you call a function. If I hide this p dot part, it is very much similar to the way you call this function. So when you call this function, what will happen? Your program will come here. It is saying x gets the value 2, y gets the value 3. So when this executes, it will become something like this. Okay. So now you see we have, although it is not a very good idea that we are giving fixed values, but since it is your first example, so I'm trying to keep it as simple as possible. Now it is like initializing x and y to some values like 0, 0, 5, 5, 2, 3, whatever you want. So since we cannot directly give value to x and y, so now if you see it visually, what we are doing, let me just explain to you this diagram. Now you see main has some, main is requesting this function because main can access this is green line, that please set the value of x and y. And now this function is setting the value of x and y. Now what is important is, as someone was asking, you see this is the boundary of the capsule. So within this boundary, anything can access anything. It means this function can access this. This is red, but this is red for main. For this, it is not red. Okay, so it means the boundary which I have drawn here, in code the boundary is this thing, this bracket and this bracket. This is the boundary. So within this class, anything can access anything, right? So although x is private, right? But you are accessing it from this function, and this function is also in the class. So if you see from here, if I have say another function called, let's call it f1, it can also access it. If I have another function f2, it can also access it. So when we say access is restricted, access is restricted from outside this class. Access is restricted from outside this boundary. Within this boundary, anything can access anything, right? So this is basically what we mean by public and private. So the key point in this example is that you, after dot with the object, you can write anything which is public. You cannot write anything which is private. From within the class, anything can access anything. Any function can access any other data member, right? But from outside the class, you have to be careful that outside the class, we only access something which is public. If something is private, we cannot access it.